This is slide number 2 in the supplemental material, and here I've talked about signal averaging. In NMR, you typically do not just run one scan. You'd run like 8 or 16 or 32, some power of 2. And let's say you run 8 scans, and what happens is the spectrometer collects 8 scans, averages it all together, and gives you one spectrum. Same thing if you did 1,000 scans. You'd collect 1,000 scans, and you'd average it all together, and you'd call it one spectrum. And the number of scans is controlled by a parameter called NT, the number of transients. And if you want to know what its current value is, you just type it in the command line NT question mark, and it'll give you back what it's currently set as. And you could also set it to anything you wanted to in the command line just by typing NT and then some number. Whoops, that was a crazy one. Say NT equals 512, and you just hit enter and it changes it. And in signal averaging, as you do more scans, the signal adds as N. And as you do more scans, the noise adds as the square root of N, because there's some random components to it. And therefore, the signal to noise as a function of number of scans is just this ratio of signal to noise is N over the square root of N. N is the same thing as the square root of N times the square root of N. And so the two square roots of N's cancel out, and you're just left with the square root of N. And so the signal to noise as a function of scans is just equal to the square root of N. And we're assuming everything else is held constant. So in this example, let's say you run an NMR sample, and you get a signal to noise ratio of 1 when you do 16 scans. How many scans would you need to do in order to double the signal to noise? And so we set up a ratio. So we have a signal to noise equals 1 is equal to the square root of 16. That's the number of scans that we did. And we want to double the signal to noise, and that's equal to the square root of what? And so we solve for x, and we get 64 scans. So the important thing here is that anytime you double your signal to noise, or you want to double your signal to noise, I should say, of your spectrum, you need to do 4 times the number of scans that you originally did. And so if you want to double your signal to noise where you're at, without knowing this, you would think you would just do twice as many scans, but in reality, you need to do 4 times the number of scans. And that applies to anything. Let's say if you had NT equal to 10,000 or 1,024, you're going to need to do 4 times the 1024 to double your signal to noise. And that's all going to add spectrometer time. And you can type this directly in the command line. You could say, actually, NT equals 4 times, and I could actually scratch this out, NT. So it looks at your previous setting of NT, which was 1024, and just times it by 4 and sets that as the new NT if you do this all in the command line.